Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we're going to talk about similar figures. Now, I'm going to begin the lesson like this. Let's say that in your home, you have a 47 3/4 inch tall scale model of the Statue of Liberty. Well, the model of the Statue of Liberty looks exactly like the original 151-foot statue. They look exactly alike. The only difference is the model is a replica of the original statue. It's smaller. Therefore, you could say that the original statue, and its scale model are similar figures. So when we talk about similar figures, they are the exact same shape, but not the exact same size. So in the case of these two triangles, triangle ABC is similar, and that's what this symbol means right here. This means similar to triangle DEF, and this is called a similarity statement. Now, like the congruence statement, the similarity statement is written to where the corresponding vertices are in the same order. Therefore, point A corresponds with point D, point B corresponds with point E, and point C corresponds with point F. Now, let's examine these similar triangles. Well, we could say that the corresponding angles are congruent. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So the corresponding angles are congruent. But obviously, not the corresponding sides. They're not congruent. But they do have sort of a relationship with each other. They are proportional. And what do I mean by proportional? This means that the length of segment AB over the length of segment DE equals the length of segment BC over the length of segment EF equals the length of segment AC over the length of segment EF. So when you're talking about similar figures, their corresponding angles are congruent, but their corresponding sides are proportional. And this leads to the actual formal definition of similarity. Two figures are similar if and only if all pairs of corresponding angles are congruent and all pairs of corresponding sides are proportional. Now, we mentioned that all pairs of corresponding sides being proportional, meaning all the ratios of the sides are equal. This means that all three of these ratios reduce to be the same thing. So let's say they reduce to give you m over n. Then m over n would be the scale factor from triangle DEF to triangle ABC. Or you could say that n over m is a scale factor from triangle ABC to triangle DEF. So now I'm going to show you some examples how we use definition of similarity to solve problems. So let's say for each pair of similar triangles, find x. Well, we have two angles. One of them is 5x plus 4. The other is 6x minus 5. Well, if you remember, if the triangles are similar, the corresponding angles are congruent, meaning that 5x plus 4 equal 6x minus 5. So now we solve the equation. We'll start off by subtracting 5x from both sides so that we could have 4 equal x minus 5. Then we add 5 to both sides, and you have 9 equal x. The solution is 9. For number 2, we have a triangle whose sides are x plus 5 and 6, and 3x minus 1 and 8. Well, they're similar. Their sides are proportional. That means that x over 5 over 3x minus 1 equal 6 over 8. We're going to solve a proportion, and we do that by cross multiplying. Therefore, we have 8 times x plus 5 equals 6 times 3x minus 1. We apply this distributive property. We have 8x plus 40 equal 18x minus 6. We're going to subtract 8x from both sides, and you'll have 40 equal 10x minus 6. We add 6 to both sides, and you'll have 46 equal 10x. Divide both sides by 10, and 10 can't go into 46, but it can reduce to 23 over 5. Therefore, the solution is 23 over 5. Number 3, we have two triangles, one with sides 4 and 2, and the other with x plus 4 and 5. Where they're similar, the sides are proportional. Therefore, 4 over x plus 4 equal 2 over 5. We're going to cross multiply. 4 times 5 is 20. And this is 2 times x plus 4. So now we solve the equation. We do the distributive property. This is 2x plus 8. We're going to subtract 8 from both sides, and you will get 12 equal 2x. And we'll continue the equation up here because we're running out of room. Divide both sides by 2. 12 over 2 is 6 equal x. And 6 is the solution. Let's look at number 4. They're similar, meaning that 6 over 5 equal x plus 7 over x plus 4. We cross multiply, we get 6 times x plus 4 equal 5 times x plus 7. Distributive property, we get 6x plus 24 equal 5x plus 35. We subtract 5x from both sides, and you'll have x plus 24 equal 35. And we'll write it up here because we're running out of room. We're going to subtract 24 from both sides, and you'll have x equal 11. Therefore, the solution is 11. Number 5, we have two angles. When the triangles are similar, their angles are congruent. Therefore, 5x minus 17 equal 3x plus 37. We subtract 3x from both sides, and you have 2x minus 17 equal 37. We're going to add 17 to both sides. Therefore, 2x equal 54. We divide both sides by 2, and you will get 27. Therefore, the solution is 27. Finally, number 6. Now, it may look like one triangle, but it's actually two. We have the smaller one here, and I'm going to change colors. And we have the larger one. Okay. So now we have 3 over 7, and I'm going to change colors so I can make a better illustration. 3 over 7 equal 6 over 7. And that's x plus 6. So x plus 6. So now we're going to cross multiply. This is 3 times x plus 6 equal 7 times 6 is 42. We're going to apply this distributive property, so we have 3x plus 18 equal 42. We subtract 18 from both sides, and you will have 3x equal 24. Divide both sides by 3, you get x equal 8. Therefore, the solution is 8. So the main thing to remember is that when the triangles are similar, angles are congruent and sides are proportional. We have demonstrated this solving these problems. But now we're going to take it one step further with word problems. Let's say a 5-foot tall boy casts a 12-foot shadow. If a flagpole casts a 36-foot shadow, what is the height of the flagpole? Okay, to work with word problems, you're going to have to draw it out so that the problem can make sense. So, let's see. Here's the boy who is 5 feet tall, and here's the shadow, which is 12 feet. Next, we got a flagpole. We're looking for the height of the platform, flagpole. We're going to call it H. And its shadow is 36 feet. So when you draw out the triangles, you will see that the triangles are similar. Therefore, we got to set up a proportion. So you have 5 over H equal 12 over 36. So what we're going to do, we're going to cross multiply. And you'll have 180 equal 12H. Divide both sides by 12, and you will get 15. So the solution is 15 feet. Now let's do one more word problem. It says here that Ramon places a mirror on the ground 45 feet from the base of a geyser. He walks backward until he can see the top of the geyser in the middle of the mirror. At that point, Ramon's eyes are 6 feet above the ground, and he is 7.5 feet from the mirror. Use similar triangles to find the height of the geyser. So as you can see, this time, the figure is drawn for you. So now we have x over 6 equal 45 over 7.5. We cross multiply 7.5x equal 45 times 6, which is 270. We divide both sides by 7.5, and you will get 36. So the solution is 36 feet. The main thing to remember for similar triangles is that corresponding angles are congruent and corresponding sides are proportional. If you remember those two things, you can solve problems regarding similar figures. And of course, and this goes for all of geometry. When you're working with word problems, draw it out so that the problem can make sense. I hope that you have a wonderful and blessed day.